This video will be about square root functions. So when you are working with square root functions, the first thing it's going to ask you to do is to find the domain. When you're looking at a square root function, the graph kind of looks like it starts in the middle of the nowhere and then goes to the right, or it could go this way, could go to the left. But let's just look at one at a time. So when you're looking at one like this, the domain is all the x values. So we have an x value here and all the way through here. So like this would be all the numbers bigger than whatever this starting number was. So to find it, usually you're given an equation. So I'm going to put a couple of equations here. So when you're looking at these equations, all you really have to do to find the domain is to take what's under the radical itself, so in this case x minus 2 on the first one, and set it bigger than or equal to 0. If we take x minus 2 greater than or equal to 0 and solve that, we have the domain. So we still, just like with equations, we do opposites. Our first opposite is to add 2 to both sides. That would give us x greater than or equal to 2, and that would be the domain. You do the same thing for each kind. Everything under the square root would be the 2x minus 5. We set that greater than or equal to 0. We do our opposites. We'd have to add 5 to both sides. 2x is greater than or equal to 5. Then divide both sides by 2. So x is greater than or equal to 5 over 2. On the last one, you just have to be careful. This plus 7 is not under the square root, so you're only using the 3x greater than or equal to 0. Nothing to add or subtract on this one, but we can divide both sides by 3. So x is greater than or equal to, and 0 divided by 3 is 0. So when you find the domain, you just take what's under the radical and set it greater than or equal to 0 and solve. The second thing they can have you do is to match a graph to an equation. So my graph is not going to be great since I'm drawing it by hand. I'll try and be as accurate as possible though. So it wants us to match this graph to an equation. And it'll give us a list of equations. So if we're not sure which equation is correct, what we're going to do is we're going to take points on the graph and plug them in. This starting point is the point 2, 1. If I plug in 2 for x, I should end up with a 1 for y. So for example, if I take this one and I plug in 2 for x, 2 times 2 is 4, and square root of 4 is 2. But y should have been 1. So that one is off the list. So let me try the next one. Plug in 2, we have square root of 2 minus 2 plus 1. 2 minus 2 is 0, plus 1 is 1. That one looks correct. They can try to trick you though, so you either need to check a second point, or you need to check all the answers to make sure. If I try the next one, 2 minus 2 is 0. And I forgot to say square root of 0 is 0. I skipped that step, but square root of 0 is 0, so then 0 minus 1 is negative 1. So that doesn't work. 2 plus 1 minus 1. 2 plus 1 is square root of 3. Square root of 3, I don't have my calculator nearby, but I believe it's approximately 1.7-ish. Minus 1 is 0.7-ish. Either way, not 1. So that one doesn't work either. So B would be the correct answer. So the last thing with radicals is called a translation. When you translate a graph, you take what they call the parent function and move it around. Y equals square root x is the parent function. It starts in the middle, and if you were to move it around, slide it up or slide it down, slide it to the right, slide it to the left, all those movements actually have specific ways they interact with the equation. So first, you could add a number, so there's the parent piece, you could add a number on the outside. That number on the outside will either move it up or down. And actually, when it's outside, they usually use the letter K. So to keep that the same, I'm going to change that to a K. So K, when it's outside, if K is positive, your graph moves up. If K is negative, your graph moves down. The second type of translation is if you put an extra number inside. Usually they call that H. Now K makes sense, positive up, negative down. H is opposite of what we expect. When H is positive, we're going to move left, which is not what we expect because on the graph to the right is the positive direction. Being under that square root makes it act kind of oddly. Then if H is negative, we move down. Sorry, not down, right. So we have moving up, we have moving down, we have moving left, we have moving right. So if I were to give you y equals square root of x plus 3. This is under the radical, so it's h. It's positive, so we move left, specifically 3. If I had something like this, y equals square root of x minus 5. This is outside the radical, so it's k, it's negative, so we move down, so down 5. Now something that can help anytime you're graphing is a graphing calculator. You may not have one of your own, but there are some websites. Specifically, the one I use the most is called Desmos. You'll start on this website, Desmos, you launch your calculator. And this can help you check any graph. And you just type it in exactly as it's written. If we wanted to graph the parent function, y equals, square root is down here, square root of x, it'll automatically graph it for you. If you ever need to make predictions or find points, you can, usually this is harder because I'm on a tablet, it would be easier on a mouse. There we go. It showed for a second. But you can actually click on the graph itself and it will show you a point. I apologize, this is much harder on the tablet. But it will show you points as you go along the graph. So if it ever asks you to predict something at like day 8, you could go up and it would click on there and you could click the point and it would show you, well, that's exactly 2.73 or whatever it happens to be. If you ever want to compare to the parent graph to see a shift, y equals square root of x minus 2. You can see right away, red was my starting, blue has moved 2 to the right from that. You can also check the ones where we plugged in values. You can check those as well, but those are a little bit harder. 5 square root x. These can be a little more difficult because when you're trying to compare to the graph they have, it may look about the same. What you've really got to check is exact points. So like it crosses exactly at 0, 0, and then the next time it crosses exactly is 1, 5. So if you could find points on the graph you're comparing to, then you can use this. But it's a good idea to still plug in points and double check. And then my keypad disappeared because I was doing things. You can bring it back up or put it back down. And you can also zoom out or in if you need to. Once you've made a change, if you want to go back to the basic setting, you can go to default zoom. So to recap everything, we first learned about domain by always taking what was under the square root and making it greater than or equal to 0. Then we learned about comparing an equation to a graph. If you plug in values you see on your graph, it will tell you which one is the correct equation. Then later on we learned Desmos can also help us check. Again, we'd still want to compare points from graphing on Desmos to the picture they gave us. And then we learned about translations. If the number is outside the square root, positive moves you up, negative moves you down. If it's under the square root, positive moves you left, negative moves you right. And again, you can check your translations using the graphing calculator Desmos. That concludes our discussion of square root functions.